So far we've been able to take a look at how atoms are bonding together, and you guys have been doing a really good job with figuring out how many atoms are going to be in a particular compound. Today what we're going to do is we're just going to get a little bit more complicated and take a look at bigger compounds, bigger molecules, and being able to count accurately how many atoms are in those compounds and molecules. We're also going to take a look at chemical equations. And the law of conservation of mass. Two really important things when we're talking about chemistry. So here we go. Chemical equations. What's really nice about chemical equations, it shows you what's going into the reaction and then what comes out. And we're going to call what goes into the reaction the reactants, because they're reacting together. Okay, so these are the substances that undergo a change. They are on the left-hand side. So if I take a look at my chemical reaction right here, hydrogen plus oxygen, those are my reactants. They are going to bond together covalently. They're going to change their properties a little bit. They're not going to, when they come out of this reaction, they're not going to look like hydrogen by itself and oxygen by itself anymore. What we get out of the reaction is always on the right-hand side. Those are my products. Okay, so that's a brand new substance formed as a result of that chemical reaction or that chemical change. So water, even though it's made up of hydrogen and oxygen, has very different properties than hydrogen and oxygen themselves. So these are my products. Okay. So reactants are on the left because they react together, and then what's produced is on the right-hand side, and that's my product. All right. So really quick, I want you guys to just check, make sure you guys understand. Take a look at this chemical reaction right here. So we have sodium and chlorine making table salt. I want you guys to figure out what the reactants and products are for that one, and then also do the same thing really quick for carbon and oxygen making carbon dioxide. Hopefully you guys figured out that sodium and chlorine, these guys over here, so the Na plus Cl, those are my reactants because they're reacting together to make sodium chloride, which is NaCl together now. And then over on the second one we have carbon, which is C, plus oxygen, which is O2, giving CO2, carbon dioxide. All right, so it should be, hopefully it's really easy. You can just, draw a dashed line in between these two things where we get that arrow. This side is going to be reactants because they react together, and then the right-hand side are my products. And what's really nice about these chemical reactions, we can see what goes what to make our products. But in both these cases, you got one of each thing, and they all add up to whatever went in there, right? But let's take hydrogen, which is H2. Remember, they like to bond covalently, plus O2. Okay. Again, we'll put our little dash line in there, continue that down. Okay, what does that make? You guys know this. It makes water, right? But when we write water, what is it? It's just H2O. Okay, you should see a problem here, right? There's only one oxygen on the product side, two oxygens on the reactant side. So we've got a problem, okay? And what we need to do is take a step back and take a look at something called the law of conservation of mass. Now the law of conservation of mass says that when we have chemical reactions, the mass, all the stuff that makes up the reactants, must always equal the mass, okay, all of the stuff that makes up the products. Okay, mass of the reactants must equal the mass of the product. So what goes in must come out exactly. Okay, that is the law of conservation of mass, and we've got, when we have H2 plus O2 giving water H2O, we don't get that. Okay, but doesn't this happen? Well, yes, it does. So what we'd have to do is we'd have to rearrange this chemical formula a little bit. But what I want you guys to understand is whatever goes in, the amount of it, in this case we have 4 atoms, must come out. So we must have 4 atoms over here, or we must have the same. Okay, so taking a look at another example down here, we have charcoal. Like if you got a fire and you're grilling out or something like that, you've got 1 kilogram of charcoal plus oxygen. Charcoal plus oxygen means it's going to burn. Okay, altogether, if you add the masses together, 1 kilogram plus 2 kilograms is equal to 3 kilograms, right? 3 kilograms of reactants, again, reactants on the left side, products over here on the right hand side. In this chemical reaction, the products are going to be carbon dioxide, CO2, plus ash, right? Now if you think about it, when you burn charcoal, you're left with just a small amount of ash left over, right? Okay, so that is kind of confusing with this law of conservation of mass thing, right? It says what goes in must come out, but it doesn't really look like it. And the reason why it doesn't look like that is because we get a lot of carbon dioxide being released as a gas into the atmosphere. Okay, but more importantly, okay, how much mass is left over here in the products? Okay, well, if you take a look at how much mass we started with, 3 kilograms, it has to be 3 kilograms over here on the right hand side, because the law of conservation of mass says that what goes in, the mass of the reactants has to equal the mass of the products. All right. So whenever we have chemical reactions, always remember law of conservation. What goes in must come out. All right. Now we're going to get into your notes a little bit. So kind of follow along with me, fill in the blanks as we go. There are certain rules that we're going to use when we're taking a look at counting atoms. And the very first one you guys know, and you've known for a long time. Okay, it just deals with how we write the elements or the molecules, compounds in the equation. Okay, the first letter right here is always a capital letter. So when you're writing compounds and things like that, whenever you see a capital letter, okay, that is its own element, that's its own atom, that's its own thing, right? So this guy right here, Ag, okay, A should help you guys see, okay, now this is a brand new element because that's capital, but this little guy right here, the lowercase g, goes with the A, okay, because you know you can have elements on the periodic table that are 2 letters, all right? But if I take a look at the rest of this thing, it's going to be important for you guys to realize that there are 3 different atoms in here. Okay, take a look at the capitals. However many capital letters you see, that's however many atoms you have. So I've got 3 capitals in this one, so I have 3 atoms. In H2O, I've got 2 capital letters, so I have 2 atoms, or 2 different, I should say 2 different elements in this particular thing. Okay, 3 different elements, not atoms. Okay, I misspoke. You have 3 different elements in that particular compound. So that's rule number 1. Rule number 2 for counting atoms deals with the subscripts. Okay, so follow along in your notes, guys. Subscripts only refer to the atom that they're behind. Okay, so an example would be H2S. Okay, so this 2 right here is the subscript. Okay, so the 2 tells me that there are 2 hydrogens in this H2S compound or molecule. Okay, right here, there are only 2 atoms of hydrogen and only 1 atom of sulfur. Okay, that's what this is saying. Now, there isn't a number 1 behind the sulfur, but if it makes you feel better, you could write in a number 1 behind the S just as like a placeholder to kind of help you see a little bit better how many atoms of sulfur there are in this particular molecule. All right. So subscripts refer to what they're behind. Rule number 3 deals with coefficients. Now coefficients are going to be applied to the entire compound, so it's going to be applied to every different element in that compound. And what you're going to do is you're going to multiply the coefficients and the subscripts together to figure out how many of each there are. Okay, so really quick, this big number right here is the coefficient, whereas this number down here, this little number 2, is the subscript. Alright, coefficients, the big number, subscripts are the little ones. So, really quick, I want you guys to try and figure out how many atoms of hydrogen there are, how many atoms of sulfur there are. The rule says that we're going to multiply the coefficients times the subscripts. Okay, so for hydrogen, we're going to take 2 times 2. Okay, 2 times 2 should mean that there are 4 atoms of hydrogen. Now for sulfur, we're going to take 2 times the subscript for this guy is, remember, just 1. So 2 times 1 is 2. Add them all up together, we should get 6 altogether. Now, in your notes for Rule 3, you've got 3NaO2. Really quick right now, pause the video, see if you can figure out how many atoms of sodium, how many atoms of oxygen are in that particular compound. The next rule, kind of our last rule, is dealing with parentheses. Now what we can do sometimes is we can, in these formulas, we can separate groups of elements within a bigger compound. Okay, to kind of show you guys an example, here we go. We have Ba parentheses OH. Okay, so OH is separate all by itself compared to the barium right here. Okay, now the rule says that if an element or compound is in the parentheses, okay, then the subscript that's behind it, this guy right here, our little number, subscript, is going to be applied to everything on the inside. Okay, so this number 2 can go here, and this number 2 can go right here as well. So if we try and figure out the number of barium atoms, what we're going to do is we're going to take a look at, are there any coefficients out front? No, so we don't have to worry about that. It doesn't have a subscript, but we can put one in there. So barium has a subscript of 1. If we take a look at how many barium atoms there should be 1. If we take a look at the number of oxygens, okay, subscript used to be 1, but now we have our subscript outside of the parentheses, which means that it's applied to everything on the inside. So we should have 2 atoms of oxygen, and then also 2 atoms of hydrogen. Okay, so that subscript applies to everything on the inside. In your notes, guys, you've got Ca3 parentheses PO4. What I want you guys to do is really quick try and figure out if you can count all the atoms for the calcium, for the phosphorus, and for the oxygen. So pause the video, see if you can do that, and then we'll check in class together. So let's do a little bit of practicing. Alright, so really quick, we've got magnesium chloride, MgCl2. Really the only rule that we need to worry about is rule number 2 with our subscripts. We've got a subscript of 2 here, we've got a subscript of 1 right there. So if we take a look at the number of magnesium atoms, okay, number of magnesium should be 1, and then the number of chlorine should be 2. Okay, again, I'm going to take a look at my compound, try and figure out how many rules I've got. I've only got rule number 2. I've got 2 subscripts in here now. There's no coefficients, no parentheses. So really, you guys should be able to figure that aluminum has 2 atoms of aluminum, 3 atoms of sulfur. All right. So a little bit more practice. What I want you guys to do really quick, somewhere on your note sheet, see if you can figure out how many atoms of hydrogen there are, how many atoms of sulfur there are, and how many atoms of oxygen. So just really quick, pause it somewhere on your notes, see if you can figure out the answer. Should have 2 atoms of hydrogen because the subscript is 2. The subscript for sulfur is just 1. Oxygen has 4. All right. See if you can do this one too. You got CH3OH. Pause the video, figure it out. Alright, so this one is kind of tricky. You've got carbon here, subscript 1, hydrogen here, subscript 3, oxygen, subscript 1, hydrogen, subscript 1. So if we take a look at how many carbons there are, okay, there should just be 1. Now here's the tricky part. Number of hydrogen atoms, you should have 4, because you've got 3 and then 1. You're just going to add those together. Even though they're kind of separated in here, okay, you're going to add those guys together. And then finally we just have 1 atom of oxygen. Okay, I'm going to make it a little bit tough on you guys. See if you can figure out this one. You got 2 Ca3 parentheses PO4 4. You're trying to figure out the number of calcium, number of phosphorus, number of oxygen. Pause it. See what you can do. Alright, so rules in this one, we have subscripts, right? We have subscript here. We have coefficient, so we have to remember to multiply that times everything in this entire compound. And then we also have parentheses out here. Alright, parentheses is applied to everything on the inside. Okay. One thing we didn't talk about is what you're going to do with these guys right here. You're just going to multiply those guys together. So if we take a look at calcium, 2 times 3 is 6. So we should have 6 atoms of calcium. Phosphorus, you've got a subscript of 1, but it's now 2 because we've got this thing outside the subscript outside the parentheses. 2 times 2 is 4. And then if we do 4 times 2 is 8. 8 times 2 should be 16 now atoms of oxygen. Alright? So in class what we're going to do is we're going to go through all of these different examples. We're going to go through the rules. Make sure you guys understand the rules because this is going to be really important for understanding chemical equations and law of conservation of mass as well.